In this video, we're going to talk about the beginning of section 4.2 on experiments. You're going to be able to distinguish between an observational study and an experiment in this video. Also, we're going to discuss confounding and confounding variables and when they appear and how to deal with them. So first of all, let's talk about observational study versus experiment. An observational study observes individuals and measures variables of interest. But does not attempt to influence the responses. So if you are running an observational study, you are simply an observer, someone who sits back and just watches and does not make any attempt to get in there or intervene at all. If you're attempting to actually do that, though, that's what's called an experiment. But an observational study does this and tries to describe some group or situation. It may want to compare groups or try and examine relationships. An experiment, though, on the other hand, deliberately imposes some treatment on individuals to measure their responses. So here's where you're looking for that cause and effect. Which one is preferred for measuring effective change in one variable on another? That's going to be an experiment. When you as an experimenter actually go through and create a situation and influence or attempt to influence the response variable, you are more in control of the overall situation, the control groups, the variables. So you can kind of whittle down what the cause and effect relationship is. In an observational study, you're not really in control of anything. You are just observing. Even the environment could be out of your control, really, because you're just sitting back and observing. So in an observation, we can't or we aren't controlling and imposing a change. This means that you're most likely to have a confounding variable in an observation, or even a lurking variable, something that's explaining some of the change in the response variable. We can't see it or observe it. Okay, and in an experiment, those confounding variables are easier to try and control for, or at least try and predict. This little blurb I put in the notes has to do with the reason why we do observations. You may think, well, if observations are so weak, why do we even have them? What's the point of doing them? One reason is that if we're trying to examine relationships, and the experiment, if performed on humans, would be unethical. So, for example, if we were going to determine whether or not parachutes actually work on humans, we'd have to actually run trials of people jumping out of an airplane without a parachute, which is just nearly impossible. Or if you wanted to find cancer rates among smokers, you can't force people to put their lives in danger to see if they get cancer. It's just, you can't do that and still practice medicine, for example. So that's why there's observational studies, because sometimes you just simply can't do an experiment with what you want to examine. But experiments are always preferred to observational studies when trying to find a cause and effect relationship. But observational studies have their place in statistics. So you're going to be able to explain the concept of confounding and how it limits the ability to make cause and effect conclusions. So confounding occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. So it's not that you can't distinguish the two variables, but you can't determine what their effect on the response variable is. Which one's having the bigger effect or which ones actually have an effect. You can't distinguish that, and that's confounding, which means you have one variable that you have or that you're actually controlling for, and then one variable that's confounding in the experiment. So I have an example here in the picture. If we're trying to study weight gain, measure how much weight where people are gaining by simply by their activity level. One of the things maybe we don't control for is age, and maybe that's a confounding variable. Even if you try and control for age, though, if you try and do different age groups and to measure weight gain versus activity level, it could be that their metabolism is different. It could be their diet. Are we controlling for diet? There's a lot of things you got to concern yourself with if you want to eliminate all the confounding variables, or at least control for those. So your effect on observations. An observation will not be effective enough to justify. To justify a relationship. If there is a confounding variable. But again, even though they're weak in that spot where the observation, you can't really tell that confounding variable, they have their place. We simply can't have controlled experiments on very negative things or treatments on humans. It's not ethical whatsoever. All right, so you're going to be able to identify experimental units, explanatory and response variables, and treatments in an experiment. So treatments, it's a specific condition applied to the individuals in the experiment It can be a combination of specific treatments or specific values. Of several explanatory variables. So it doesn't have to be just one treatment. It could be a combination of them all rolled into one. Experimental units, or we call them subjects when they're human. You can use subjects for other types of experimental units, but mainly with their humans, we're going to call them subjects. They are the smallest collection of individuals to which treatments are applied. So in a given experiment, you're going to be able to identify all these things: treatments, explanatory variable, response variable, and experimental unit. So in this example here, a researcher wants to identify the effect that alcohol has on mammals' ability to navigate. The researcher uses mice instead of humans and either gives them 0.05 milliliters of alcohol in their water or doesn't, then has them navigate a maze. Times are kept for each group of mice from the start until the end of the maze. Identify the subjects, treatments, explanatory, and response variables. Okay. Subjects. What's being experimented on? That's your mice. Treatments. Either you're given or not given 0.05 milliliters of alcohol. And then your explanatory and response, in this case, your explanatory is going to be alcohol use or usage. And response variable is your maze time. How much time it actually takes for the mouse to make it through the maze. So just to recap, experimental and observational, they are different ways of measuring similar things. If you are running an experiment, you're actually imposing a change on the subjects. If you are running a observational study, you are simply observing and nothing else. You're not controlling it for anything. And what that does is it actually allows for confounding variables to get in there and mess with your results. So they are significantly weaker in trying to determine cause and effect relationships, but they should exist and do exist because you simply can't do certain experiments on humans or even other animals. It's inhumane or unethical to do. So they must exist for some reason, or for those reasons out there, but they are weaker with the cause and effect relationships.